Hi, this Boost Your BIM video will show how to align a straight wall with a curved grid. We can see here we have two different straight walls and a curved grid near each one. Let's show you how this works and then talk about the code. Pick a wall, then I pick a grid. You can see that the wall's endpoints were projected onto the grid and all inserts were recreated on this new wall. We can also use this case here at an angle, pick the wall and pick the grid. And now let's take a look at how the code works. So we start off here, we prompt the user to select the wall on the grid. We get the curve from the grid and we get the line from the wall's location line. We get and then take the direction of the wall's line, and here use the cross product with the z direction to find the vector perpendicular to the wall's direction. So in that case, with this wall, we're finding a direction that would be like this, and this wall, we're finding a direction like that. Next thing we're going to do here is I created an intersect method that we'll take a look at. What this does is it takes an input of a point, a direction, and a curve. And so the idea here is that we want to, for example, take the endpoint of this wall and project it onto the curve to find this point of intersection, and to do the same thing at this end to find this point here where that line or that direction from the perpendicular to the wall at this point, and then where that will intersect with the curve. And here we'll take this curve and also one that would be over here like this and find that point of intersection. We'll also use this to find the new location for the inserts that are in the walls as well. So the way this works is we have said the point, a direction, and a curve. I'm going to create an unbound line. This means it's a line with infinite length. It takes an input of a point and a direction. The point is going to use the x and y values of the input point, but then for the z, I'm going to use the z of the curve. This was done because, for example, with the window's location is going to be up because the window is, has some sill height of 3 feet or whatever. And so I want to put that point down on the z height of the curve so that there will be an intersection. So here we intersect that unbound line with the curve, give some error message if there was no intersection. If there is, we find the intersection and return the point of intersection. So this gives us, we are going to find 3 points for the wall, from the two ends and then also from the middle. So if we look at the case here, would have those 2 points and then also a point somewhere around here for the middle of the wall. We're going to do that so that we can then create an arc using 3 points, the two endpoints and then a midpoint. Next, we're going to find the children of that wall so that we can recreate them in the new wall. So that's all the family instances where the host has the same ID as the selected wall. Now we start a transaction. We start to create some elements. We create the new wall using that arc created by the 3 points of intersection. We'll set the wall type of the new wall to be the same as the type of the old wall. Then go through all those children, in this case the doors and windows, get the point of the location of that insert. Then do the same intersect we talked about before to find points on the new wall where the new inserts will be created. So that's approximately points here, here, and here. So we create that new family instance, and then want to try and match the properties of that new instance. So we check to see if the original instance had its facing direction flipped, and if it did, then we flip the facing of the new insert, and the same thing if the hand was flipped, and then finally we delete the old wall. And again, that's how we go from a wall with windows like this to the wall here, recreated on the curve of the arc of the grid with its inserts intact.